time again for another video presentation. This time around we're going to talk about simple circuits. So our simple circuits are going to be two kinds of circuits. That's series circuits and parallel circuits. So we'll start with series circuits. And the idea of series circuits is that everything in the circuit is connected in a row. So here you have a series circuit where there are 3 light bulbs all in a row. Now each one of these light bulbs could offer some resistance. So really what these circuits are going to come down to is applying Ohm's Law to circuits. That's what it comes down to. And of course there'll be a current, there'll be a voltage, and there'll be resistance. And the resistance is each one of the objects that you put in the circuit. Also, as we know, the wire itself creates a resistance. But for these series and parallel circuits, simple circuits, we'll disregard the resistance of the wire itself for the most part. Okay, so connected in a row. Because they are connected in a row, the current is constant in the circuit. It's the same current that's flowing throughout the entire loop, and everything is on the same loop is a way of looking at it. Disadvantage here is that if one of them goes, they all go. And as I said before, everything that is put in the circuit creates some resistance. So here's a little bit of a diagram here of a series circuit. This is how they indicate the battery is being in there, and each one of these lines over here indicates a resistor. So this is something where there are 4 things on the circuit here. And a good example of a series circuit are the old Christmas tree lights. They would put all those ornamental lights up, and you know, if one of them went out, they all went out. You might have some familiarity with those. I don't know. But yeah, this is the symbol for a resistor that's put in the circuit. Okay, so let's see what else we got. Because we are talking about individual resistors here and a current that is going around the circuit, here you have a longer line indicating the positive and a shorter line indicating a negative. That's standard for batteries. So here you have a battery maybe that is running around a circuit, and there's the 3 resistors in the circuit, resistor 1, 2, and 3. Okay, yeah, so for a series circuit, the total resistance of the circuit is the R1 plus R2 plus R3. Just add up the 3 resistors and that'll give you the total resistance. And then you can apply that with the current and the voltage to figure out, to solve for the things that I'll be asking you to solve for. Okay, now each one of these currents here is going to have what they call a voltage drop. Each one of these resistors, I should say, is going to have what they call a voltage drop across the resistor. So when you add up each individual voltage across the resistors, that gives you the total voltage. So in this example over here, we have a voltage drop across the first resistor of 10 volts. Don't think of a drop as something going down. It's just a terminology for the amount of voltage across each resistor. So what's the total voltage for this circuit here? It's 10 plus 24 plus 36. So let's see, 36 plus 24 is 60, and 60 plus 10 is what, 700 or something like that? All right, 70. So 70 would be the total voltage over here. And that's the idea here. Here's the diagram that shows the electron flow, and this is the way we look at it, that the electrons are let go on the negative side, and they flow across each one of the resistors over here. In the negative, flowing toward the positive. So that's the way they flow here, from negative to positive. Okay, so here's a diagram here. But in this diagram, it's going from positive to negative. It's kind of interesting here. In some places, they'll talk about the flows as going from positive to negative. And in the old days, that's the way they thought about it. And still in some books, you're going to see it indicated as going from positive to negative. It's really arbitrary, all this positive and negative stuff. You still get the work done. Okay, so here's the total voltage V, and they're showing each one of the individual voltages as well. Alright, so this is what I'm saying. In some books you're going to see it going from positive to negative, and some you're going to see it going from negative to positive. I think our book is more in the negative to positive, which is the up-to-date version of looking at things. All right, so here you see some different resistors. So the total resistance here would be, you can see there's different resistances for each resistor. Each one's going to have a different voltage, but the current stays constant all the way through. Okay, that's about it for series circuits. And now what we're going to do is another kind of simple circuit, and that is the parallel circuit. So let me just call up that presentation here, and we'll take a look at that one. I inadvertently canceled it out there. All right, so let's see. All right, and parallel circuits. All right, parallel circuits are more the way your circuits at home will probably be put together. And the advantage of the parallel circuits is there is branching going on. So the current can go to different places. And that means if you turn off one of the appliances or one of the light switches off on a circuit, all the other things can still be working because they're not in series. So that's the advantage here. If one bulb goes out, your circuit is not dead. All right, it's voltage that's constant for a parallel circuit because it's the same voltage across each of the different loops where the current could be flowing. So here you can see with the different resistors, the points across each one of them they're in common. So it's the same voltage. So where in a series circuit, it's the current that's constant. In a parallel circuit, it's the voltage that's constant. Okay. All right, so the current has different places that it can go. Here's a diagram showing you that the current could go toward one, or it could go toward the other, or it could go toward the other. So the current has some choices. And here you see the negative charges flowing. All right. So now the total current is going to be adding up each of the individual currents. That's going to be the deal for the total current. Now, there's a little bit of a difference here for talking about the resistance. We don't just add up the resistances here to get the total resistance. The total resistance, R, 1 over the total resistance is equal to 1 over each one of the individual resistances. And here's just one where you have 3 resistors. It could be 4, it could be 7, it could be 2. I think you get the idea. But the total resistance, it's 1 over the total. The 1 over the total resistance is equal to adding up 1 over each one of the individual resistors. And maybe in class we can talk about why that's true. Maybe you can figure it out on your own, or maybe we can talk about it. But really, if you look at the idea of resistance in a series and a parallel circuit, I think you might now be up to all of the equations on the AP equation sheet. So that's a pretty big deal anyway. Sometimes instead of like a battery, you would call it an EMF, an electromagnetic force source. That's something that creates electrical potential, or voltage, I guess you could be saying. And that is it for our simple circuits. I'll leave some practice problems up there for you. And very good. I think we're through simple circuits for sure. Thank you for looking, and if you had any confusion on this, please bring your questions to class. I'll look forward to seeing you there.